Paragraph 1. We probably picture tiny shiny things in the sky at night when we think of stars. That's how they look from Earth, but you can see that stars aren't small. In fact, Betelgeuse, one of the biggest stars, is a lot bigger than our Sun. Scientists have had no idea what this star is for years. However, Betelgeuse has been experiencing a more disturbing event lately, which has made scientists and other knowledgeable people very worried. The James Webb telescope says that Betelgeuse will soon be destroyed. In this article, we'll look at the scary details of this new event and how it will affect our galaxy and our lives here on Earth. Paragraph 2. Makaku, a scientist, said that Betelgeuse is a cosmic wonder and a big star that has fascinated cosmologists for a long time. Tmy, a Greek scientist, was the first person to find it. We can see this star from Earth in the winter because it is so big. This star is probably something you've seen or heard of if you're into constellations. The star that stands out in the upper left corner of Orion is the reddish-orange one. In other words, this star is very old, and it is still one of the brightest in the sky at night. Paragraph 3. The fact that Betelgeuse's brightness doesn't stay the same is an interesting fact in itself. One of the interesting things about this star is that it changes shape, but it's not the only one. Let's look at some of the other unique things about Betelgeuse. A lot of the stars you see at night are very far away from Earth. Earth is 4.2 light-years from the nearest star. If you still don't get what light-years mean, think about it this way. Imagine going through the air at light speed for a whole year. A light-year is the same as 186,000 miles per second, which is how far light goes in 1 year. There are a lot of miles between them. Paragraph 4. Being 4 light-years away means that the star is billions of miles away from Earth, but some stars are even farther away and Betelgeuse is one of them. Being 600 light-years away from Earth means that even if you could move at the speed of light, it would still take 600 years to get there. Not even our fastest spaceships can move that fast. It's still very bright in the sky though. Betelgeuse is so bright even though it is far away. This is because of its size and brightness, among other things. Paragraph 5. The size of Betelgeuse is about 500 times that of the Sun. It is thought to have a radius about 1,000 times that of the Sun. Betelgeuse is so big that it looks like a disk when seen through powerful binoculars, while other stars just look like points of light. Scientists think that reactions in the top layers of its atmosphere cause it to look like a disk. It takes between 12 and 19 solar masses to measure how heavy Betelgeuse is. Astronomers use the solar mass as a common unit of mass. 1 solar mass is equal to /2 times 10 carat 30 kilograms. Because there are no other planets circling around Betelgeuse to compare it to, scientists can't say for sure how heavy it is. Paragraph 6. It is true that Betelgeuse is at least 12 times heavier than our Sun, but we can't measure it directly from Earth. When it comes to light, Betelgeuse is between +0 and +1.6. In simple terms, Betelgeuse is 16,000 times brighter than the Sun. That's why people call it the red giant. But Betelgeuse's brightness changes because it pulses. To put it another way, Betelgeuse grows and shrinks. It gets brighter when it grows and less bright when it contracts. This process can last anywhere from 10 to 100 days or even longer. Paragraph 7. Betelgeuse is also one of a kind because its surface is covered with dark magnetic spots. In these spots, the magnetic field is much stronger than on the rest of the surface. However, these strong magnetic places stop hot gas from moving to the star's outer surface, which makes those areas cooler. Because it has so many more of these spots than the Sun, Betelgeuse is cooler than the Sun, even though it's bigger and brighter. There are dark magnetic spots on the Sun as well, but the ones on Betelgeuse are bigger and more numerous. Paragraph 8. To give you an idea, Betelgeuse's spots can be twice as big as Earth's. The magnetic field around Betelgeuse is 1,000 times stronger than the Sun's. The gases on the surface of Betelgeuse look like they are forming loops or arcs when seen through a lens because of this strong field. About 3,500 Kelvin is how hot the surface of Betelgeuse is, which is much cooler than the Sun. The dim red color of Betelgeuse is partly caused by its low temperature. Paragraph 9. It wasn't always red though. Betelgeuse was yellow about 2 million years ago, just like our Sun is now. Its color changed slowly over time to an orange-red, and around 2,000 years ago, it turned into the red star we see today. Some experts think that Betelgeuse is almost dead because of this change in color. It gives off about 7,500 times more energy than the Sun. That star could have been a real threat to the Sun if it were closer and still in its best shape. Paragraph 10. At night, Betelgeuse can be seen with the human eye, even though it is 600 light-years away. Our Sun, on the other hand, is only 8.3 light-minutes away from Earth, which is why it has such a big effect on it. We might be able to see Betelgeuse during the day if it were closer, but if it took the place of the Sun, it would be so big that it would push Earth and the 4 closest planets out of the way. Also, Betelgeuse gives off a lot more energy than the Sun, so even if it did fit, it would be a bad star for Earth. Paragraph 11. So maybe it was never meant to be our Sun. Maybe it was just meant to be a red giant far away that we can enjoy. Because Betelgeuse is so far away from Earth, its red light is stronger. Light waves from objects and galaxies are changing because the universe is expanding all the time. Longer wavelengths move farther because of this. From far, far away, only red light can be seen because blue light fades since its wavelength is shorter than red light's. Paragraph 12. Betelgeuse has been very interesting over the years, but one thing is still clear. It is an old star that is almost done with its life. As stars age, the hydrogen in their bodies changes into helium through a process called nuclear fusion, turning the stars red. This is when the star starts to slowly change into what scientists call a red giant. We know that stars that are heavier age faster than stars with less mass. Paragraph 13. Stars that are lighter tend to age more slowly, but stars with more mass age more quickly. Betelgeuse is dying faster because it is 12 times heavier than the Sun. Betelgeuse's irregular pulses and changes in light provide more evidence that it's nearing the end of its life. In 2019, Betelgeuse began to dim, reaching its lowest brightness in February 2021. This caused scientists to worry that the star might soon die. But how do stars end? An explosion or supernova occurs when they blow up. If you've ever seen a nuclear blast, you might have an idea of what a supernova is, although it's far more powerful. When stars reach the end of their lives, they explode in a massive, intense blast called a supernova, sending huge amounts of energy into space. Paragraph 14. Supernovas are among the most spectacular and awe-inspiring events in the universe. There are 2 types of supernovas, Type 1 and Type 2. A Type 1 supernova occurs when the remnants of a low-mass star gather matter from a nearby star until they reach a point where they can no longer hold any more. This causes a nuclear reaction that blows up the star. High-mass stars, like Betelgeuse, go supernova when they exhaust their fuel and can no longer maintain their structure. This leads the star to burst, releasing an immense amount of energy. Most Type 2 supernovas emit light, heat, and radiation, and some are powerful enough to destroy everything in their path. Sometimes, a Type 2 supernova can be so bright that it outshines all the other stars in its galaxy. Paragraph 15. Heavy elements like iron, nickel, and gold are also created in Type 2 supernova explosions. These metals form during the high-pressure, high-temperature reactions when the star bursts, and they spread into space. As they disperse, they contribute to the formation of new stars and planets. So, what kind of explosion might we expect from Betelgeuse? It will likely be a Type 2 supernova. Michio Kaku, a renowned physicist, has expressed concern about this, suggesting that Betelgeuse could explode soon. Whether this would be good or bad news depends on the circumstances. Paragraph 16. The last supernova observed in our galaxy was in 1604. While supernovas are often beautiful and produce bright colors, they are also extremely dangerous, and it's wise to keep a safe distance. What would happen if an explosion from Betelgeuse reached Earth? Supernovas emit intense, high-energy light, which they all have in common. A typical supernova releases a burst of radiation that is 1,000 times more powerful than the Sun's radiation. Considering how harmful the Sun's rays can be, especially with concerns over global warming, imagine something 1,000 times more intense. Radiation from a supernova could damage Earth's ozone layer, and the shockwave alone could cause serious harm. If it reached Earth, it could trigger another extinction-level event, potentially wiping out almost all life on the surface. Paragraph 17. Some scientists believe that the only way humans could survive such a radiation blast would be to go underground. Earth's surface is the only shield capable of absorbing this level of radiation. We might have a chance at survival if we adapted to life underground. However, some cosmologists and experts argue that we don't need to worry about Betelgeuse's supernova at all, given that Betelgeuse is so far away. But science is constantly evolving, and every day we learn something new. For instance, the James Webb Space Telescope recently discovered 6 massive galaxies in space, each the size of our Milky Way. Until recently, scientists didn't believe galaxies of this size existed, forcing them to reconsider their understanding of the universe. This raises questions about what else we may not fully understand, including our proximity to Betelgeuse's supernova. Paragraph 18. Our knowledge of Betelgeuse is still developing, especially with new technologies like the James Webb Space Telescope. We don't know what other surprises Betelgeuse may hold. Its pulsations are already fascinating, and its supernova could be even more remarkable. Particles from a Betelgeuse explosion could potentially reach Earth faster than light, or the shockwave from the explosion could trigger another nearby star, like Capella, which is only 43 light-years away, to erupt. If a star that close exploded, Earth would almost certainly be affected. Paragraph 19. But let's say the blast doesn't reach us and we remain safe. What other effects might we experience after Betelgeuse's explosion? Most likely we would notice light effects. A supernova mainly emits light and energy, so people worldwide would be able to see Betelgeuse's bright light in the sky. Scientists predict that a massive star like Betelgeuse could emit such a brilliant light that it would even be visible during the day, like a bright star near the sun. Moreover, some believe that Betelgeuse's supernova could shine brighter than the moon. Paragraph 20. The intense light from a Type II supernova doesn't last forever, so we wouldn't have two moons permanently. Typically, the light lasts between 2 weeks and a few months, so Betelgeuse's supernova might shine brightly for at least 2 months, then fade away. What would happen to Betelgeuse after it explodes? It's expected to leave behind a black hole in the years following the explosion. Black holes often form when massive stars explode. Betelgeuse might leave a patch of faint light, but even that light will disappear in a few more years if a black hole doesn't form. Paragraph 21. The last question is how soon Betelgeuse might explode. We're uncertain. Some experts suggest the supernova could happen 1,000 years from now, but because the star is dimming and pulsating right now, those estimates might be incorrect. Michio Kaku, a prominent theoretical physicist, has issued warnings indicating that Betelgeuse may be close to collapsing. This could happen within the next 100 years, 10 years, or even 2 years. When scientists first noticed Betelgeuse dimming in 2019, they discovered that a portion of the star's outer layer had blown into space. We don't know for sure, but this could have been a sign of an imminent supernova. Paragraph 22. We can only wait and see. Thanks for reading. Click the thumbnail of the video on your screen to watch another exciting episode. I'll see you there.